Alright, so today we are looking at second derivatives. So today we'll just look at the process, and then the next lesson we'll look at what we can actually do with them. So second derivative, to get a second derivative, you differentiate twice.
I wouldn't recommend this.
Alright, so the symbols that we use. So in function notation, two dashes, f double dashed x, and in Leibniz notation, it's d2y dx squared is the notation that's used to indicate a second derivative. Alright, so let's have a look at three examples. So first, a reasonably straightforward one. So 6x to the 4 minus 4x cubed plus 4x. And if we want the second derivative, we've just got to differentiate twice. So the first time we differentiate, we get f dashed x, and that would be 24x cubed minus 12x squared plus 4. And then to get the second derivative, we now differentiate that result. So 3 lots of 24 is 72, is it? So 72x squared minus 24x. And then of course the number, and there it goes. So there's our second derivative. Alright, that one's pretty straightforward. Sometimes there's a little bit more mucking around. Alright, so this time we've got e to the x times sine x. So to differentiate, we use the product rule, correct? Alright, so the product rule. So I'm going to go u equals e to the x. B equals sine x, du dx equals e to the x, and dv dx is cos x. So dy dx then is e to the x times cos x plus e to the x times sine x. And then we need to differentiate again to get the second derivative. So if I split it into two parts, then this part, the e to the x sine x, well, that's just what we did here. So we know that this e to the x sine x bit then is going to become e to the x cos x plus e to the x sine x. And now I need to use the product rule on that part. So if I go u equals e to the x, and v equals cos x, u dx is e to the x, and dv dx equals negative sine x, I believe. Alright, and so then when we put that together, we get e to the x times negative sine x. Put all this together at the end here, so my second derivative. Alright, e to the x times negative sine x, so negative e to the x sine x, write it like that, plus e to the x cos x, and then we've got this part that I've done in blue. So plus e to the x cos x plus e to the x sine x. Alright, so this first part there is that green one. It's differentiating this one. And this part on the end is differentiating this bit, which of course is what we did here. So I've just used that result. Now, what do we notice? Anything? Cancel out the e to the x sine x. You've got minus 1 there, plus 1 there. And the other bit is we've got two lots of that, so we've got two lots of e to the x cos x. Alright. So a bit more involved, a bit more looking around there, but processes, techniques we used are ones we've used before when we just differentiating the first time. Alright, one more example. You're right for me to rub that off. Yep. Alright, last example. So if we've got e to the 2x, fx equals e to the 2x, and we're asked to find f double dash 0. So first step would be to find the second derivative of our function. So we've got to do that in two steps. So when I differentiate e to the 2x, I get what do I get? 2e to the 2x, of course I don't. And then when I do that the second time, it's going to be 4, yes. So the 2 comes down again, multiplies by that 2 that's already there. 4e to the 2x. So what we're asked to find was the second derivative when x is 0, which is well done. No one wants to commit this morning, do they? All right. So that's all we're about today, is just looking at the process. Tomorrow we'll look at what we can use them for.